we're talking about texture in Opengl. So Opengl kind of works in two phases. One is primitive transformation, kind of if I have a cube or if I have a triangle or if I have any shape, first transformation happens. It rotates and translate and kind of then it scale whatsoever. At the end, when transformation is finalized, then after that rasterization happens. So, like if I have a triangle and I start rotating it and translating it, so if I am translating, if it is going far away, then it becomes smaller, and I can scale it. Once finalization happens, then coloring starts. Okay, so means I know this area I need to color now. So if triangle was kind of in front of me and I rotated 45 degrees, so area to color is kind of small. So one finalization of the pixel happens, finalization of the fragments happen, then fragment start getting the color. So typically in Opengl coloring starts from the vertex because we don't have any way we can start coloring each pixel. Vertex color we can specify. From the vertex, if it is a smooth shading, then there will be estimation for the each fragment for the coloring. And once the fragment coloring estimated, then coloring would happen. It will take care of the depth, of the kind of depth also. If a particular parameter is behind the scene and depth is selected, then that will be colored. Okay, so coloring is a tricky. I cannot draw a picture. Just I can select so many vertices, infinite vertices, and draw each vertex with each color to make a human, to make a brick wall, to make a kind of earth shape, to make a planet. Not possible. So one human cannot draw a kind of an image of anything. Maximum he can set the vertex kind of for simple images, for simple coloring, but for a complex coloring to kind of put forth an image or like a brick wall, I say that a wall which is made of bricks. So that much fine images through vertex coloring is not possible. Okay, so how we can per fragment colorization, how we can do that to kind of realistic, that would match a human, that would match a kind of any photograph. So texturing come into the picture. Okay. So I have an image, and that image would get pasted on a frame. So that is texture. I have an image of a river, and that river image should get pasted on the pyramid. Okay. So in digital world, it's not that straightforward. The way we think that I take a wallpaper and just stick it. So in digital world, everything happens digitally. So one image is kind of it has a set of pixels. So if I have an image, then it is set of pixels, it is called pixel. Now the computer monitor is pixel, whereas the image pixel is texel. Okay. Now if I have texel, then how texel color would be kind of chosen, how I can estimate. So in images, if we see the coordinate on the screen, then it comes into the kind of window coordinate. Window coordinate is kind of whatever is feasible for a programmer. Like I want -1 to 1, -1 down to up, -1 down to up 1, -1 left to 1. Okay, and near and far. So this is the way a programmer wants. So that comes to window coordinate. So if I say I want to select a pixel at -1 in x and 1 in y and z1. So this is how somehow it will decide for a pixel. Okay, so, but in image this philosophy doesn't work. So in image the bottom left is 0 0, right is, so bottom left is 0 0, so right is 1, rightmost, and topmost is 1. So x can go maximum 1 and topmost can go maximum 1. So once we, now the idea is how we can paste an image on a primitive. So image coordinate system is like this. There is no minus, there is no beyond 1. So between 0 and 1 in x direction and 0 and 1 in y direction. Where 0 0 is left and bottom corner. So that is the kind of idea. So if I specify 0.5, 0.5, then 0.5, 0.5 would not meet the exact texel what we are thinking. So texel color, now like if I draw and if I color and kind of a vertex, I say GL color. Now instead of GL color, now texel color, the pixel color of the image at that position would go now as to become GL color. So there is a texture unit. Texture unit is a kind of a sampler which samples the image, and if I say 0.5, 0.5, it will return the exact color of a texture at that location. So this is how it starts happening. So whatever the pixel, now I can map from image to primitive. So image is 0 0, then I can say in primitive it would be kind of 0 0. This side 0 0, that side 0 0. Means the left bottom corner of the texel should color the 0 0 location pixel. So whatever the actual color of the texel that comes from the sampler unit, that is the texture unit, and that color from the image go and drawn as GL color at the top. Okay, so this is texture. Now there are many things that comes in texture. So instead of mapping kind of texture image to primitive directly, we come with a kind of concept called texture object. So we have texture object, we have texture unit. Texture unit is a sampler which convert the kind of any location in the image that is called strq. Instead of x, y, z, w, it is strq. So any strq to a particular color, so that it converts. Now image gets an image object status. Since it is the object, there is an ID. Data of the object is the image itself, and it has many operations. So image object is a new concept in kind of in Opengl. So instead of calling it image object, it is called texture object. It's kind of a fancy name. So it is a texture object. If I have a texture object, it has an ID. If I have a texture object, it has a data, that is the image data. If I have a texture object, then it has operations. The way the object philosophy, that like an object or class should have data and operations, methods. So methods are operation. So what can be operation that we can kind of provide through texturing? So typically two kind of operation generally we see. Like I have a brick image. I want to draw a brick on the primitive. Primitive is a kind of rectangle. I don't want a full brick to be shown in rectangle. I want 10 bricks to be shown in rectangle. So a brick should be repeated on the rectangle. So as we described that textual coordinate cannot go beyond 1 and it cannot be less than 0, but we can now specify. I can say 0 to 10. Even though the maximum is 1, so it will repeat. So the operation on the texture object, so I have texture unit as a sampler. Texture object is another guy which keeps the image data inside and provide operation. So if it is kind of, if I specify, what is the scenario if my kind of the coordinate unit goes beyond 1. It goes below 0, -2 to 2, -2 to 10, in X direction, Y direction. What would be its property? So that operation that we have to see. Okay. So this is one operation where kind of we want to repeat or we want to clamp like this. One kind of operation is mag and min filtering. It's called filtering. Filtering in the sense like image density is more and pixel density is less. Like in an image, one particular area has 10 by 10 pixels, whereas it has to map only on one pixel. Then what would be the algorithm? Or if pixel is 1, but on the pixel side, the image density is less and pixel density is more, then how one pixel would map to 10 pixels? So this is magnification. One is magnification, means one pixel would map to many pixels. One is minification, that is many pixel would map to, many texture would map to one pixel. So these are the operation on the texture like filter. Okay. Another idea is the texture functions comes into the picture. Like rather than drawing only the texture pixel, texture color would be the color of the primitive. We can go for something kind of blending or some modulation of the color, means mixing the actual color there and texture. So we can have many functions there. So that comes into the picture. Third thing is kind of MIP mapping. So MIP mapping, like if texture density is high, texture density is high, in one particular area there is 100 by 100 texture, whereas in that area on a screen there is only 5 by 5 pixels. So in this kind of scenario, if we start reducing the size of the image on the screen, then there will be mathematics to minify. So to minify, result would not be kind of very aggressive if minification is very high. So what can be done is, I mean, if an image is very big on the screen, it is getting reduced, kind of we are zooming out and it is becoming small. Then minification from the texture, that appearance would not be kind of very small. So we create images at each level, kind of that is multiply, that is kind of exponential of 2. So we can select, we can have 5 images. One is 64 by 64, 32 by 32, then 16 by 16, 8 by 8, and 4 by 4, and 1. So once minification starts, rather than doing the mathematical computation from the original image, then the nearest MIP map image would be selected for the image. So this gives kind of better look and feel. So MIP mapping, texture function, multi-texturing. What about in a particular primitive, I want many texture to be drawn there only, not only one texture. So multi-texturing comes into the picture. So these are the property of a texture object. So texture is not getting drawn on primitive. Texture object is getting drawn on primitive, carrying operations and image data. Then image data, how image data would be converted to kind of one color. If I specify texture coordinate, that comes from the texture unit. Texture object, texture unit. Texture unit is responsible for getting the color of a particular texture, particular coordinate, and selecting a texture through some algorithm and giving the color. And so this typically, if in kind of shaders programming, then it happens in GPU for a speed up reason. And texture object. Texture object keeps the image and it does all the operations. Mapping to a bitmap, magnification, and then repetition, clamping, and whatsoever. Okay. So we'll see that how nicely we can kind of do texturing. Texturing has light effect also. So the coloring anyway will be achieved through texture. Now coloring is gone. Means if you don't go for modulation and texture function, we can just if we are in a mood to just replace the texture color at the pixel location, then coloring is gone. So if I see from the light perspective, then there are many lighting perspectives. Then there are many parameters from the lighting perspective. One is ambience color. One is specular color. One is diffuse color. So diffuse, specular, and ambience. So diffuse is mainly the color of that color that it will show. So it replaces the real color. So it is replacing the texture. But a specular, the shiny that comes. So that calculation we'll see how we can do after the texturing happens. Because if I shine a surface before the texturing happens and texture comes on top of it, then only there will be coloring. There won't be any shining. So how we can delay, postpone the specular component of a light. Once texture happens, then we can start doing the specular calculation. So all these factors from texture unit to texture object to lighting and everything. That further to a discussion on texturing in Opengl. So we'll proceed on desktop. This is Linux Mint. Okay, so what is texturing and what we will cover? So texturing is so in Opengl pipelining, we do transformation. Okay, so in Opengl pipelining, we do the transformation of the primitives, and in the once we start coloring the fragments, then we color the pixels. So at that time, instead of pixel color, what we specify, we'll place the color from an image, a PNG image or JPEG image, whatsoever. So that is the idea. So that is texturing in Opengl. So we'll cover texturing where placing image pixel, texel color as color of the vertex. Okay. What is texture object? So texture object is the working image that is in programming. A texture image is just in reality it's a byte array. So we'll upload this byte array and we'll give more functionality to it. So more bigger status to it. So that is texture object. So texture object would work in practical scenario. Texture image would come inside texture object. It will have other thing also. It follows any object-oriented concept. Texture wrapping, how texture can be wrapped. So a texture can be repeated. Okay. So in filtering, we'll see a mag filter, main filter, texture functions. Not only the texel color would be replaced. If there is a already pixel color is available, then modulation can also happen. So that we'll see in texture function. Either modulation can happen or some kind of blending. Multi-texturing, if images are many, then how we can place it, how texture coordinate works. Okay, so how secondary colors we can apply, how we can calculate the lighting, specular, diffusive color anyway we are getting through the texture color. Post texturing happens, then a specular, the shining of the light, so that we'll see, and texture transformation. So these are the topics we'll cover. Okay, so what is the texturing? So texturing is like this is a window, and in this window, this is a particular pixel. Prior to the texturing, the color of the pixel, that happens through vertices in kind of a fixed function pipelining. So the vertices color we specify through GL color. Once we specify GL color, that becomes the color of a particular pixel. Instead of specifying through GL color, okay, now I have an image. Okay, so image pixel, okay, like image is a image of a triangle, so it's pixel color. Okay, so that is GL text coordinate. So if I have an image, okay, so image is if we see the image, if we see the general coordinate system, we have x, y, z, and fourth parameter is w. Now in image, it is strq. Okay, so strq is kind of equivalent to x, y, z. X, Y, Z and W. So this is the coordinate for this kind of window. So equivalent is strq. Okay. So this is the current scenario. So S is X, T, Y and R is in Z direction, and Q is the fourth parameter. Value would be kind of interpreted as per the requirement. Now if this is the image, then bottom left is 0, 0 and bottom right is 1, 0. Corner is 1, 1 and this is 0, 1. That's it. Means there is no window coordinate or whatever we want, we can specify -1 to +1, -10 to +10. It is fixed. So this is kind of texture coordinates, and we have to say a particular coordinate. Like if I say a coordinate is kind of 0.4, 0.5, then 0.4, 0.5, whatever the color at 0.4, 0.5, that would become color of a particular coordinate, particular vertex. Okay, so earlier it was GL color. So if I am saying GL vertex, okay, so if I am saying GL vertex, okay, so when I am drawing a primitive kind of GL begin and GL quads, and in this primitive I am setting now GL color 3F and whatever the color is, and then GL vertex 3F whatever the vertex is. So This is the current scenario. For a particular vertex, this is the color. Now we can erase this. GL text coordinate 2F. So for that particular vertices, this is the color at location 0.4. Okay, so this is replacement by the texturing. So kind of we can mask this, not required. So this is the current scenario in OpenGL texturing. Okay, so in OpenGL texturing, the coordinate system is strq and it is fixed between 0 and 1 in both directions. And GL color is replaced by GL text coordinate. So coloring of the vertices now it is being taken from image, and image is kind of it is coming here. Means this obviously if image pixel would come as color, then image would be kind of the new pixels. So that is the idea. Okay, so texture object. So if I have image, this is the image that is in kind of binary image, and this binary image, okay, so this binary image is becoming an image data of a texture object. So we create a texture object. Inside that we push the image data, okay, and how we push from image to image data, that is through GL image 2D. So GL image 2D is kind of it reads the image and create image data. This image data belongs to a texture object. So that is the architecture. Okay, now there are many other things, like we talked that texture object, inside texture object image data comes. Now image data, that is one image is mapped on the actual window. So one image is mapped on the actual window with these coordinates. So what if we want this kind of scenario? Image should be repeated, or image should be kind of mirrored repeated. Image should be clamped. Whatever the image boundary is, that should be clamped to the actual window. And if it is not clamping, then there should be a border. Red color is the border. So if this kind of scenario is required, then it is called texture wrapping. Okay, so this is the kind of we are mapping. Text coordinate -1, it maps to vertex -2, -1. Text coordinate -1, 2, it maps to coordinate. So we specify a quad, and inside the quad we are setting the vertices. Against each vertices there is a mapping of the texture coordinates. Okay, once we map this texture coordinate, then we have to kind of specify the texture parameter. So we say texture 2D, texture color, border color, and texture 1000. So this is for bordering. So what is the actual grammar that we use for this GL repeat? Okay, so the actual grammar, what we use is like this. Okay, so if what is the whole process, like what we need to do and those kind of things. So in the code, we need to write like this. GL text parameter, GL texture 2D, okay, and GL texture wrap S, GL repeat, okay. So if someone writes this function GL text parameter like we specify here, GL text parameter, GL texture 2D, DL texture wrap S. S means in X direction, S means in X direction, T means in Y direction. So these are the kind of image object properties. We talked about image object, and in image object the data is the image, and image object has properties. So one of the property, the text parameter, it should be GL text property, means it make more sense. Okay, against this text GL texture 2D image, we have, if we want to wrap the image, then it should be repeat. What is wrapping? Wrapping in the sense, there is a possibility that means I am specifying 0 to 1. If I specify 0 to 1, the GL texture image would map exactly. So if this is the image, this should map exactly covering the, like this is the, like it should be considered as map to 1 1, means 0 to 1. Okay, if I map, like this is the example code. If I map -1 to -1, -1 -1, -1 to 3 to 3 1, means if I specify coordinate that is less than 0, it is 0, left side is 0, right side is 1. If I specify right side coordinate more than 1, top is 1 maximum. If I specify top more than 1, bottom is 0. If I specify bottom less than 0, left is 0. If I specify left less than 0, in that scenario, the texture would start repeating. I mean, it should do something else. What it should do? We should specify property like this. So these GL text parameter, these are the property of texture object. And property is repeat. If I specify repeat, then this image would repeat. Like I am setting -1 -1, left side is -1, okay, right side is 3, top is 2, okay. So this would repeat 4 times in X direction, I mean in S direction, okay. Now the bottom is -1, top is 2, left is -1, right is 3. So it would repeat 3 times in T direction. Now instead of, so I have set wrap as S and T both as GL repeat. Now this GL repeat can be changed to mirrored repeat, to clamp to edge, to clamp to border. So these are the scenario. Clamp to mirrored repeat, okay, clamp to edge, clamp to border. This may change when we see MIP mapping. And this is the GL clamp to border, okay. We'll talk about MIP mapping also. I think it's not listed here. Okay, so MIP mapping would come in future, so that we'll see. Okay, filtering. So these are the scenario. If image want to be repeated, then or image, if there is extra space, then there should be a border of, or it needs to be clamped. That this is a scenario. There is another scenario called filtering. So in filtering, now if I have image has a texel density. So image pixel is called texel. So image has texel density, and this is the window. So window has pixels. If pixel density is less than texel density, then many texel would map to one pixel. Other way, if pixel density is less, in texel density is less, and pixel density is more, then one texel would map to many pixels. So this is called minification. This is minification. More texels are minified in a one pixel, or magnification. One texel would be magnified to many pixels. What can be algorithm? So this is again can be set the way we saw. Okay, so again there will be a program like this. In program we have to specify like this: GL text parameter GL texture 2D. If we are taking 2D texture, GL texture mag filter. So what mag filter we want? So we can specify like GL nearest. Okay, so this is the kind of a code we need to provide in the. Okay, now for min filter we can again write this command. So GL texture 2D GL texture min filter GL nearest, or whatsoever, means whatever we feel GL linear. Okay, so this code we need to write. Okay, so if we write this code, this would come into picture. So if minification is happening, if texture density is higher, what would be the scenario? Nearest. So so we'll take the kind of so against this pixel we'll take the nearest texel. Linear will average all the texel, and that will take. Okay, GL nearest. So MIP map will see there are kind of so if we do minification, in minification scenario, if the actual image density is very high and minification, the window is becoming smaller. Okay, so in minification, if we are changing the window size to smaller, or we are scaling the image to small, then in that scenario, this minification algorithm may not work very nicely. Means too much mathematics to happen from the same image, source image. So instead of that, we'll have many sub images, and calculation would happen from a sub image that is near to the size of the window at that time. So that we'll see in MIP mapping. So nearest is the nearest texel would be taken. Linear is kind of average. Nearest, GL nearest texel, and MIP map that would be near, or MIP map would also be get averaged, and texel is nearest. MIP map nearest texel is linear, and MIP map linear means MIP map will get averaged, and this is nearest. So that scenario will also talk. In mag filter, nearest and linear. So in magnification, there are not more options because our image itself is kind of inferior. In that way, either we choose the nearest texel, or whatever texel is around will do average of it. Okay, so this is the scenario for the filtering. So we talked about texture object. So texture object has image data, and in image data we are doing operations. One operation is wrapping. How image would appear if coordinate is bigger? Filtering. How image would appear if texel density is not similar to same as the pixel density. So these are the operations on texture object. Okay, so I have an example. Like this is this column is nearest, and this column is linear. So in this algorithm, if we take the nearest texel, what will be the scenario? Or if we average the around, if 6 texels are around a particular pixel, then we will average all the 6 texels. So if image density is very high, in that way, means it doesn't make much sense if we take nearest or linear. Okay, if we take nearest or if we take linear, then there are too many pixels, so it won't make much difference. But if image density is low, in that sense min filter makes sense. If image density is low, okay, then mag filter would make sense, in the sense that if it is the nearest, then we can see it is a kind of zigzag images, because whatever comes nearest it is taking. So it will take this image, this pixel, or this pixel. Here lot of pixels are there, so no problem, but here problem will happen. So it will create a kind of aliasing effect. Or if we want linear, then it would average the pixel around. In that sense, we get a smoother whatsoever. Information is not rich. So, but it would look smoother because there is average of the texels. Here, whatever texel, one texel is coming, whatever is the nearest. So this is low density image. So in low density image, nearest and linear make sense. It is different. High density image, it is not different. Okay, so this is filtering. Okay, so now we'll come to object model again, means texture object. So what we saw, okay, so if I have an image, that image is read through GL text image 2D. So this is the API. If I use this function, then image from the box memory is read and it becomes image data. If we specify GL text parameter and we specify some property, then there will be a texture wrapping. If we specify GL text parameter and there is a property magmin, then there is a filtering. Altogether, this is object. This is texture object. Okay, so this is texture object. This is texture object. Now, since this is a texture object, there is an object name or object ID. There are operations. Since it is an object, so there are operations like texture filtering, texture wrapping, we saw, MIP mapping, we'll see. texture function, specular lighting, secondary color. There are so many operations on texture. So texture object is the guy that gets executed, not the image. Now texture object, okay, so in object oriented technology, it aggregate image data. It doesn't compose image data, but it aggregate image data. And texture object is depend upon a texture unit. So once we specify the image data, okay, so like if I say kind of the argument is 0.4, 0.4. So this is the texture coordinate. If this is the texture coordinate, what would be if this is the texture coordinate, 0.4, 0.4, then what would be the texel color? So now our texture image requires sampling. Once sampling happens, if I specify texture coordinate against the sampling, then there would be a guy which would return the texel color. So this is the guy, texture unit. If texture unit receives coordinate, okay, so texture unit receives coordinate and it returns the texel color. Okay, so it takes the coordinate as input and it returns the texel color. So that is texture unit. Okay, so this is full-fledged texture object. It has operations and it has data, and then it is kind of calling texture unit and to get something done. Okay. Okay, so this is about the texture object. Now we'll see the texture function. Okay, so in here we have texture object, and then we have texture wrapping, filtering, texture function. Okay, so we saw the texture wrapping means in texturing, there is a texture, there is a polygon, kind of triangles or triangle strip, triangle fan, quad. So texture has to be mapped on the polygon. Now polygon receives coloring from GL color. So there is a color like green, and through GL color polygon receives the coloring. Through GL text coordinate, again it receives the coloring from the texture. Okay, so we saw filtering and wrapping, texture object. Now texture function kind of there can be idea like if I specify a color through GL color, then pixel color is GL color like green here, and if I specify GL text coordinate, then pixel color is this. Okay, so what about modulating this color? Kind of modification. So both, this and this, can we bring both kind of mixture, kind of blending, kind of adding, kind of combine, kind of decal, kind of modulate. kind of replace. So replace anyway we are doing. If I do replace, then whatever the color is specified through GL color, and that will be replaced by GL text coordinate. Otherwise, whatever is there. So function that is used in this scenario is GL text environment. So GL text environment, we can specify its kind of the parameters, and then here dot dot is this. So in this fashion, we can have kind of a mixture of the color and texel color. So that is texturing function. Okay. Okay, so next is multi-texturing. So multi-texturing is kind of a superset of everything. Here we have background as color. On top of it, we are placing the texture, and then we are using these kind of parameters what we want. Multi-texturing is superset of everything. I have kind of color. On top of the color, I have one image. On top of the image, I have another image. On top of the another image, I have another image. Then finally rasterization happens. So can we mix kind of a background color and then so many images, and finally it would end in a kind of a result image. So this is multi-texturing. So multi-texturing is quite complex, and if we understand the concept, then probably it wouldn't be that complex. So if I have an image, now we have placed here texture unit. So if I have an image, that image is converted into texture object. So texture object is a object that kind of contains the image data. So like any class and object, like C++ class and object, Python or Perl, so whatsoever. So if there is an object, it has data. So data is the image data. If it is an object, there is methods. So these are the methods. So texture object is ready. I can use texture object to fetch the data. I can use texture object to have the methods. Who uses it? If there is a image data and it has properties, then who uses it? Texture unit uses it. So texture unit is the guy that actually executes. So why texture unit? Why texture object? Image data is not kind of what we are looking like. We can see in this scenario. Image is this. This is the image. But after doing some manipulation, image becomes this. So this is the actual image now, not this. So this is through repetition. Or if I do clamp to edge, clamp to border, then this is the image. So image we are changing. If we are changing the image, then one bigger guy will come into the picture. That is called texture object. This is not texture object. Because image we are modifying, so we can't rely upon the image. Once we rectify the image, we modify the image, that next the kind of the end image is different. Now this image need to be manipulated. Now if I want pixel color at 1 and 1, that is top right, okay, this should be from this image, not from this image. It should not be from this image. It should be from this image. So one guy comes into the picture, that is called texture unit. So texture unit goes into texture object and it calls it functions, and then it returns the color of the coordinate. So if I say the coordinate is 0.5, 0.5, it comes into the middle. So this is white, whereas actual image 0.5, 0.5 is black. So texture object modifies the image, and that final image is being used by texture unit. Texture unit comes into the processing. So if I have OpenGL kind of OpenGL functions, 3D functions, OpenGL function, they interact with texture unit. One texture unit can only interact with one texture object. One texture object can be associated to multiple texture unit. One texture unit can process only one texture object. So if I know a texture unit, so texture unit is a guy who executes, means it has the algorithm. So it does all the computation. So it's complex. So generally texture unit resides on GPU because calculations are there. Okay, so here for each entity, for each image, there is a texture unit. Obviously, if I have an image, there is a texture object. Okay, if I have an image, then there is a texture object. Okay, so if I have an image, there is a texture object. So if there is an image like this, then there is a texture object. If there is a texture object, then processing guy is texture unit. Okay, so this is another texture unit processed by another texture unit. This is processed by another texture unit, and finally it comes to the output kind of raster image. This is multitexturing. Whatever we do in normal form, where we don't mention the texture unit, there is a default texture unit. Without texture unit, nothing happens. So here texture unit is 0, 1 and 2. Okay, so this is multitexturing. So whatever the processing texture unit 0 is doing, that output is going to texture unit 1. It mixes it, whatever, means we can specify what we want to do. And then it passes to texture unit 2, 0, 1 and 2. Then whatever it does, it passes to the final image. So what mathematics we want to do, we have to specify through GL text env. So whatever we are doing without texture unit, so everything comes under texture unit 0. So same thing we need to do. So we need to add texture unit. So like earlier we were doing GL enable, GL bind texture. These are the kind of typical texture object fundamentals. So these are bound inside a texture unit called texture unit 0. Okay. Then now we have to add 1, 2, 3, 4 and specify same thing, bind texture. So a texture object comes inside texture unit, because texture object becomes database for the texture unit. If we are using vertex array, then we have to add GL client active texture. So GL active texture is for texture unit. So these two lines are required if texture unit are more than 1. Otherwise, by default, it is the 0th texture unit. Now we have texture unit. What is job of texture unit? If I specify texture coordinate, texture unit reads it. Then it goes to texture object that belongs to this texture unit. And texture object contains the image. Texture object contains all the methods, how it will be repeated or how it will be filtered, magnification, minification, whatsoever, MIP mapping. Finally, whatever comes into the picture, then texture unit that will result into one final image, and that texture unit, depending upon the text coordinate, it would result the color of that particular coordinate. So this is texture unit. So texture unit kind of depend upon the texture object. One texture object will be associated with many texture units, but one texture unit will be it will use only one texture object. So texture unit takes texture coordinate as kind of input and output is color. Behind the scene, it goes to texture object and say, can you please do all the computations and can you give me the actual image? Once actual image is provided, then texture unit map that coordinate into the image, inside the image, and passes the color. So texture unit is kind of a high processing engine and it resides on GPU. So later we'll see the shaders programming. So that happens in GPU, and that is kind of, so now we are kind of fixed function pipelining. So inside fixed function pipelining, GPU usage is minimal or nothing. Okay, so we cannot do kind of a complex 3D graphics. In complex 3D graphics, means it requires a high speed. Okay, so this is kind of multi-texturing. I have two images, this image and this image. If I do multi-texturing, it creates kind of a hybrid image where hut is there and flower is there, both are there. This is multi-texturing. Okay, this comes under texture function cells also, because at the end multi-texturing we have to specify texture function only. So a texture function typically, like if we have color, then it can be added with the image. Here everything is there based upon the texture unit. But at the end, every texture unit will have this texture function. What it has to do with the previous image. If a texture unit specifies GL text ENB as replace, and that texture unit happens to be texture unit 2. So whatever data it is receiving from texture unit 1, that is gone. It will replace everything with this butterfly. Okay, so no one will use replace, because that's what not the intention is of using the texture unit. So some kind of add or combine or blend, modulate or decal should be used, so that the modified image, so if it receives the color, then it would do some kind of modulation on the color with the image, and whatever the new pixel colors are there, it is passed to another texture unit, and this texture unit do another modulation, passed to this, another modulation, passed to. Okay, so this is the concept of multi-texturing, and this is the example of multi-texturing, where two images are kind of blended. Okay, so this is the kind of a UML diagram of full scenario. Texture object. Texture object kind of, it realizes many interfaces. I mean, it's not like that in Opengl. You won't find any classes. But, okay, so this is a kind of texture filtering interface, which has two kind of methods, mag and min. There is a repeat and clamp where rep S, rep T and other direction. So S is X, T is Y, STR, Q. Texture environment, MIP mapping. So it realizes all the interfaces and it brings the object. It contains image data. And then, these are the kind of methods or interfaces it exports. Mr. Texture unit, it uses the texture object to finalize the image and then generate the texel color, actual texel color, not the image, input image texel color. Because input image anyway, I can have a texture coordinate and texel color, but that we have processed the image as per the texture object interfaces. So that texel color would be written by the texture unit after the processing. So texture object is associated with many texture unit, and texture unit uses the texture object. Okay, even further. So we have kind of bit bigger diagram. So this department, This full department is texture object now, and there is a texture unit, and there is a OpenGL. So OpenGL kind of it uses n number of texture units. One texture unit kind of uses one texture object. One texture object is associated with n number of texture units. Okay, so this is kind of a full-fledged UML diagram of the OpenGL texturing. I mean, it's kind of one page. That's it. Okay, like texture object, kind of it realizes these interfaces. Okay, so texture coordinate and transformation. So texture coordinate, as we have seen, if I have an image, then horizontal is x-axis, that is S, T, that is Y, and R is along z-axis, if we have 3D map, 3D texture. Okay, and how it would rotate, same as kind of right hand palm. So we have to kind of fold it, and thumb would be the direction of the axis, and then other finger would show how it would rotate. Okay, so if I rotate x-axis, along the x-axis, then we have to place the thumb along the S, and the finger, the way they are round, it will rotate the image along that axis. Okay, so texture coordinate and transformation. So texture transformation can also happen the way we have transformation in OpenGL. So texture can rotate inside its boxes. Okay, one thing. Second thing is that texture transformation is independent of the kind of a global axis. So global axis we have X, Y, Z. So texture transformation is independent of this. So texture transformation happens inside the box and whole stuff. So I have a kind of a polygon. Inside the polygon, image is drawn, and image can be transformed, rotated, translated, whatsoever inside the polygon. So this is the polygon. This is the polygon. So inside the polygon, okay, texture can do transformator, but full polygon comes inside the global text transformation kind of global axis. So two-way it can do transformation. Image transformation inside the polygon and full polygon transformation. Both we can do. Like this. I have a texture and its properties is kind of a climb to border. So there is a border color green, and this is the texture. I can rotate the texture inside the polygon. So this is rotation across z-axis, and z-axis, so its origin is here. It can be seen. So this is the origin. This is x-axis or S. This is T, and z-axis is R. I am rotating across R, and it is rotating. All complete. This is kind of a global XY coordinate. This is local XY coordinate. If it is seen, blue, red axis is there. Full image can be rotated. So rotation inside the polygon and rotation kind of with reference to the global axis. So both is possible. Okay, so secondary and a specular color. Okay, so if we see the kind of lighting, OpenGL lighting, I mean, you can kind of refer to the lighting tutorial. So in OpenGL lighting, there is a kind of a light source and there is a material. Light source emit ambient, diffuse and a specular color, whereas material has its own specular, diffuse and emission, okay, and ambient. Inside a specular there is a shininess. Here there is a kind of exponent we have not mentioned, not required. So there are four things: emission, diffuse, specular and ambient. Inside a specular there is a shininess, Okay, and it throws light, it reflects light. How throws and reflection will happen depend upon the parameter. Calculation happens like this. At the end, what would be the pixel color? There is one more guy called light model. Light model adds ambience. Okay, so this is the complete scenario of lighting. Okay, what is the problem here? Lighting, if we do the lighting, okay, like we talked about the color of the polygon, the pixel color of the polygon, it comes from the color we specify. It comes from the texture we specify. It comes from the lighting also. There is a third guy which adds the coloring. Okay, so lighting adds the coloring. Okay, so in the coloring, like ambience and diffuse, they will add the color into the polygon pixel. After that, texturing happens. So texturing kind of, if you do texturing, then lighting is gone. Okay, so there is no meaning of lighting because ambience and diffuse actually add the color. So that color is replaced by the texturing. But a specular component, the specular component that we have kind of put in a green, it's a green circle. So specular component of the material, that is the reflective, and a specular component of the light source, that we can kind of delay, and it would be added once texturing happens. So that is the scenario. So whatever we have kind of put circle in a purple color, so this calculation happens before the texturing happens. So it has no meaning if we do the texturing, but there is an option. There is an option. By default, that option is not enabled. We can do a specular, that is shining. Okay, so the shininess would also be in green. Okay, so the shininess we are talking. So specular and shininess. Okay, I think it is more or less okay. Okay, so shininess, specular. So specular component. So here in the calculation earlier, kind of we had everything calculated in one go. Now post texturing, we can make specular component kind of it will do the mathematics. So that is the idea. So vertex color, this would happen once texturing happen, all are gone, and we have option to do a specular kind of calculation post texturing. So that we can do. Like this is the example. We have texturing, and on top of it we can see the kind of specular. It's shiny. So that we can do. Okay, so okay, I think it is not mentioned here, and that is possible through a lighting model. So in lighting model, we have kind of one component that we need to enable in the lighting. So once we enable that, then it would happen. So that is comes under kind of secondary color. So we'll see secondary color. Okay, so kind of we can, it will kind of a GL light model that we have to specify. So GL light model I. So that is the API that we can use for this. GL light model I, and we have to specify GL light model color control, GL separate specular color. So if I do this in lighting model, then so it would separate the specular color. So that is the idea. Okay. Now this would be the resultant. Okay. So if we see the MIP map, okay, so we have seen in kind of the filtering what we talked. Okay, so in filtering there are two kind of filtering. Means the scenario is like if this is a polygon and this is a texture. Okay, so if this is okay, so there are two things that we have been seeing. So one is texture and one is polygon. So this is texture and this is polygon. So this is the current scenario. Okay, so texture has pixels and polygon has pixel. Now the texture density and pixel density are different. So in one case the texture density is high and polygon pixel density, screen density is low. If this is the scenario, then there is a minification happens. More texels are mapped into kind of a less number of pixels. It can happen through these rules, nearest, whatever texel is the nearest, or kind of average of the texel, that is linear, or average nearest of the texel and average of the MIP map, nearest of the texel, average of the MIP map, linear, nearest, nearest of the texel, nearest of the MIP map, nearest of the texel, okay, average of the MIP map, nearest of the average of the texel, and like so. So a new thing comes, that is MIP map. Okay, so now what is MIP map? Now this is the scenario. Texture maps to polygon and minification happens. So when minification happens, like this scenario, this is the actual texture, okay, and this is y-axis, this is x-axis, and this is z-axis. So along the z-axis, now the polygon, this is polygon. Upon this polygon, this texture is drawn. Now polygon is reducing itself. I mean, kind of the object is going far. So this is the polygon. Now it is going far. Now it is going far. Now it is going far. So every time Opengl has to draw the kind of the polygon, I mean, it would contact the texture unit for the drawing. Now texture unit will do minification of this image. So here minification is okay, kind of, I can think 2 text cell is becoming 1 pixel. Here more text cells are becoming 1 pixel, here even more, here even more. So the calculation is high. Means if I am at this point, then so many text cells from the texture, they are becoming 1 pixel. So calculation is high. This kind of lead shimmering kind of effect. Means it will kind of shimmer, means there would be a kind of like a light is glowing or something like that. So that kind of, it won't be smooth. It will be very different. I mean, we'll see in the lab session. So the when calculation is unnecessarily, we are doing this to this, not required. Okay, this is what we are talking. So when vinification happens, if polygon is big, then probably this much red, this much text cells in red area is going to become 3 pixel. If minification is more, kind of polygon sizes become even low, then it would map to 2. If it is even low, then it would map to 1. So lot of calculations are required. Not required means we can kind of kind of avoid this. So how we can avoid? So when we are kind of calculating this polygon, then we will do with respect to, not with respect to this image, okay, with respect to some smaller image. If I am doing calculation for this polygon, then I'll do with respect to this image that is near to it. Okay, so that is the idea. Means we will generate kind of a set of images. The size of the images would be half. If size of this image is, okay, so size of this image is kind of now the size of this image is 243 by 101. So the first one that will come in map would be half, so that will come to 120 by 50. Now next one will be even half, that would be 60 into 25. Okay, and the last one would be 1 by 1 this way. So that much. So these are called map images. So map images we have to create, and we have to set these map images. So if I say this, okay, so if I come back to okay, so if I come back to texture unit, then the images are being loaded through from image data. Okay, so the API that is used to load the image data is a GL text image 2D. So text image 2D loads the image into texture object. We have to call text image 2D multiple times. Okay, so text image 2D. Text image 2D. So what is text? I don't think I can do man here. Okay, so text image 2D, it accepts many, I will see in the lab session. So in GL text image 2D, it does kind of, it reads the image data, okay, and it has to specify it is at what map level. So by default means we specify map level 0. We can say a particular is at map level 1 2, 3, 4, 5. So many call we have to make GL text image, and so many GL text image would be loaded inside the texture object. One GL text image 2D would be at what map level? I mean, this is what we do. Okay, so the idea here is that we have to load image into the texture object multiple times. First time the original image at map level 0, and then many other images that I have created. So that will be at level 1, 2, 3 and level n. So we have to load into the texture object. Once texture object is ready, loaded the item. So once texture object is ready, now texture unit, which refer the texture object for the texel color that maps from a coordinate. At that time, texture unit, depending upon the whatever the texture functions we have set. Okay, so we set texture function. Texture function can be one of these replace, modulate, decal, blend and whatsoever. So depending upon the texture function, the texture object. So texture function, okay, I'm sorry. So texture unit, it refers to texture object and it refers to the map rather than texture function. So at the map we specify, so okay, so here texture wrapping. So in the filtering, okay, so too much confusion. So texture unit, now when it needs it needs to output the texel color, it refers to the texture object. Now texture object has there is one guy called filtering, neither texture function nor map. Okay, so we are talking about texture filtering. So it refers to the texture filtering. What is the texture filter? If texture filtering is any of the four where map comes into the picture, okay, in that sense it would refer the map. If even though we create the map and we don't use a filtering map nearest or linear, then even if we load so many map images, it doesn't make any difference. The calculation will happen from the map 0 level, that is the original texture. Otherwise, we can specify like I want nearest texel and map would be the nearest. Map would be the linear. Map would be the nearest. Map would be the linear. So if I say map is the nearest, then like this guy, so it will do some mathematical computation and one map it would select. So from that map it would follow what is said. So from that map, so if map is nearest, like we are saying map is nearest, in that sense it will see texel is nearest or linear. I think it's quite clear now. So if map is nearest, then it will go with the normal algorithm. Texel is nearest or average. Map may be linear. Map may be nearest. Map may be linear. If it is linear, then all around 3 or 4, all around map it would select. Okay. And it would do the averaging. After that, whatever average comes in, then on top of it, it will do nearest or linear. Okay. So Okay, what is the advantage of this? It avoids shivering, means the kind of the glare, kind of not pleasant to the eye. What we see, that would go away through MIPMAP. And at the cost of, we are generating so many images. Okay, so many images we generate, and how we refer to these images are in the filtering we specify. Okay. Okay, so this is about the theory part. Okay, same thing, calculation what we have seen. So in the kind of when we see the MIPMAP, then the way polygon is kind of becoming smaller and smaller and smaller, our texture size also becomes smaller and smaller and smaller. So less number of texels are available. So at the end, 1:1, only one texel is available to map into the polygon. So computation is very fast, and unwanted anyway, that effect we don't see. Okay, like this. Okay, so what we have in the kind of lab session now? Okay, so now we are into the lab session. And okay, so first we'll talk about the design, how we'll proceed with the lab session, and then we'll do kind of some simple texturing, and then we'll see texture function, and followed by we'll see multi-texturing. So in texture function and multi-texturing, we'll see kind of transformation also, texture transformation, and then finally we'll come to more complex texture object. So we'll have a design, we'll create texture object, texture function, multi-texturing, and after this we'll jump to kind of a vertex array texture objects, vertex array multi-texturing, vertex array texture function. Okay, and in the vertex array itself we'll see kind of a specular lighting and MIP mapping. So all the aspects one by one, kind of 6 are there that we'll see. Okay, so in design we'll have a code that comes under lab session, and it depends upon a package called Opengl utility. Opengl utility also depends upon an object file that has vertices. Okay, and then the lab session we also depend upon the Python 3 Opengl package. So we'll install this package, and we'll copy this Opengl utility module, which internally depend upon the object file. Now Opengl utility module, it has two classes, one is shape and one is utilc. Shape depends upon utilc, that is the UML diagram, and shape can be kind of subclassed like pyramid and whatsoever. Okay, so this is the design. So we will be depend upon Opengl util and this Python package, and this Opengl util module diagram is this, two classes, and utilc, shape uses utilc, we can use utilc directly also. Okay, so this is the design. Okay, so later session we will have kind of an aeroplane, and aeroplane we can we can put a texture on the aeroplane the way what we want. So same aeroplane can become aeroplane from kind of many companies depending upon its texture, and this is the reality. like we can have a sphere, and sphere, when we have something we can paste, we can kind of put a texture wrapper on top of it. So there can be many earth and globe textures are available. So that will paste. Okay, so at the beginning we'll see simple texturing and then texture functions and texture rotations. Multi-texturing we'll see. Secondary color, like we can specify secondary color. Secondary color can be in a kind of a shape like it is we can kind of do a specular shining on the secondary color. Okay, we'll see MIP map also. We'll generate MIP map and shimmering and flashing, scintillating. So these effects will kind of minimize with the MIP map. So this is all we have in the lab session. Okay, so we'll start with the simple texturing and slowly we'll proceed. We covered the theory part. Okay, according to that. Okay, so all points here we have covered. Texture transformation, texture, specular light, post texturing, secondary color. Secondary color, either we can specify secondary color or secondary color would come from the specular light, post texturing, texture coordinate, multi-texture, texture function filtering, texture wrapping, texture object. Okay, so now we are kind of all set to go. Okay, so we'll kind of install sudo apt get install python 3 Opengl. Okay, it is installed and it is 3.1.5. It is the kind of the version we have. Okay, so we'll create a directory mkdir opengl texture. We'll move to the directory and we don't have any. Now we'll see the design, what we are kind of talked about the design. Okay, so this is the place where we'll write the code. So we'll say kind of text.py. Okay, so skeleton code quickly we'll write from opengl.gl import everything from opengl opengl.glu import everything from opengl.glut import everything. From pil import image. Okay, some image. This is the way we'll read the image. And okay, not much. So we'll directly kind of jump on the init, def init. So this is the OpenGL way of writing the code. And we'll say GL clear color. The color buffer we kind of will clear. GL shade model, very important. We'll use flat. Flat in the sense kind of 1 pixel color if we set, then for the full polygon, the same color would be applied. It's not a smooth. Okay, so there is nothing kind of mathematics applied now. GL enable GL depth test. Now we'll open the image. So image equal to kind of image.open, whatever image we want to open. So we'll have an image called flower.png and we'll convert into RGBA mode. Image. Now problem is image is kind of it is flipped. I mean we need flipped opposite direction because the texture coordinate what we talked. So texture coordinate here. Okay. So texture coordinates start from bottom left, that is 0.0. But in the images, the texture coordinate starts from the top left. So we have to flip it. So image equal to image dot transpose image dot flip top bottom. Okay, so we'll generate texture now. So I can say kind of texture name equal to glgen. So this is the way we are GL textures, I believe. Now we are generating the texture object. This is what we are trying now. So texture object is being created now. So texture object has the object ID, object name. So we are here now. So we can say text object. So generate texture. And now we receive the texture object ID in the text name. GL bind texture. Now mind kind of this is the 2D texture we are using now. We are not using 1D, we are not using 3D. I think there is one more cube or something like that. So we are using 2D texture. Type is 2D texture. Now the story of this object name starts. Now we bind the object name, texture name, object ID, and whatever we do, that will be kind of will go inside this texture object. So first what we do is kind of we'll read the image. Okay. GL text image 2D, GL texture 2D. 0 is the map level. GL RGBA. So this is the kind of internal format how the image would be inside the texture object. So this is what the texture unit would see. Image.width, image.height. So these are the factors. Border will keep it 0. GL RGBA. This is the format of the image that we are kind of, so that's why we have set converted to RGBA. And it's a GL unsigned byte. Now this is the kind of the actual image. So we'll convert to bytes. In Python, it's like the way we talk, any language, English or whatsoever. Same way we write the code also. There is no scripting. There is nothing like that is hidden behind the scene. Okay, so GL text parameter I, GL texture 2D, GL texture map, texture wrap. Okay, so we are setting, we loaded the image, created the image. Now I am following texture wrapping, then filtering. So these interfaces we are setting. MIP map level 0, texture filtering will see, texture wrapping. So this is what I am doing now. So texture wrap in the S direction, and I'll say kind of GL repeat. GL text parameter I, GL texture 2D, GL texture wrap in ST direction, again GL repeat. GL text parameter I, GL texture 2D, and here we are talking about GL texture wrap T, GL repeat. I'm sorry. So the values here are GL nearest, linear, and MIP mapping. So MIP mapping will see. I can just say nearest. GL text parameter I, GL texture 2D, DL. Okay, so that was mag filter. So this is min filter. Min filter. Again we can say GL nearest. So we'll change this wrap T to kind of mag filter. Okay, so this is the code we have written so far. Okay, so first we set the wrapping S and T repeat, and mag filter and min filter nearest. So this much we have kind of achieved. Okay, that's it. Image.close. So our object is ready. GL bind texture to this object ID. This is the image, and this is the wrapping, and this is the filtering. That's it. Okay, now we can kind of we can jump to the display area. Def display. So in display we'll clear GL color buffer bit, GL depth buffer bit. Okay, okay, so GL clear, GL, oh, okay, so A is clear and CLOR is COR. So GL color buffer width, GL depth buffer width. Okay. Now we'll come to kind of our business of doing the stuff. So now I'll say GL enable 2D, GL bind texture. So that is the text name. So text name should be global because we are referring from here and there. So I can say global text name equal to something like none, and here I can say global text name. Now text name would be available at other places also. Okay, so I may not specify here global because anyway we are just using it, so it's a read only, so it's okay. Okay, and what is the function we are using? So GL text environment float, GL texture env, GL texture env mode, GL replace. Okay, so we talked about the texture environment. So texture environment, if so texture like multi-texturing, things starts from the kind of the fragment color. On top of it we specify the image. Okay, how image and the fragment color would be blended, so that is comes under texture field, texture function. So we want replace, straightforward, means whatever the texel color is, that color would come into the picture. So that is the idea. GL begin, GL quads. Now this is the kind of primitive, so quad is the polygon now, and now we can say GL text quads, quad 2F, and we can specify 0 0, and it would match to GL vertex 3F, and that is -2 -1 0 0, GL text code 2F, and that is 0 1, and GL vertex 3F and -2 1 0 and 0, GL text code 2F 1 and 1, and it would map to vertex 3F. Okay, -2 plus 2 into image dot width by image dot height. Okay, okay, so fourth coordinate I don't think we should put. Anyway, we'll remove from the first line. GL text code 2F 1 0, vertex 3F -2 plus 2 into image dot width, image dot height -1 and 0. I think we messed up, so okay, so this we don't need. Fourth, okay, so this we don't need, so we can say kind of, okay, so here we are removing the fourth parameter, so 3F it is same. Now we need here a third parameter, so we'll say like this, so Z is 0, okay. Up to this only we'll draw. So what we are doing is, we are mapping texture coordinate 0 0 to the polygon coordinate -2 -1, -2 1, -2, whatever the image width by height is, so that it should be kind of realistic. So, and so it is doing kind of clockwise, and then like this, that's it. So image we have closed, image dot close, So we'll remove this. We cannot close the image, and image is being referred as image width and height. So image would also be it should be visible. So I will say image comma none, and image is also global. Now image is also global. So whatever image we are seeing, so image is visible. Okay, so GL end. GL disable, GL texture 2D. Okay, so this is the code. So under display, we are clearing the buffer bit, depth and color buffer, enabling texture 2D. Now story is the in the texture name, object ID, and text environment is replace, and quad is like this, and end and GL disable. So this is a very simple okay. So we'll use GL flush, and then now we'll have depth reshape. So this is the OpenGL function, and here we'll have GL viewport. GL matrix mode, that is GL projection, GL load identity. Okay, so we'll use GL perspective, that is 60 degree we'll use, and W by H. If W is greater equal to H, else H by W, and we'll use 1 to 30. I think it, or 1 to 20, 30. Okay, and GL ortho will type if we need. GL matrix mode is GL model view, GL load identity. That's it. Now we'll do transformation because we have set 1 to 30. So we'll say GL translate, and in the direction of, so we'll say somewhere like 8, 3.2 or something, 3.8. So we are placing in minus Z direction so that it would be visible. Okay, we are done quickly. So name equal to main, glut init, and glut init display mode is glut single, glut RGB. Okay, glut. So this is what is the mode of this glut that what we are using. So glut init window, initial size would be like this. Okay, glut create window, and my OpenGL code, and init function will call glut display func is display, and glut reshape func is reshape. So this is the function. Glut main loop. So done. Okay, so we have written the code, means minimal code. So this is what we are using. In the init we have text name, image, clear color, and flat enable depth test. Okay, so depth we have enabled. Shade model is GL flat. We open the image, flip top but bottom, and we bind the texture name, and then we load the image. Okay, and we provide the other property, wrap property, and mag and mill filter, and then we display. So we clear the color buffer and depth buffer, enable texture 2D, bind texture name, texture environment is GL replace. We are using quads, and end disable flush, reshape. Glut init display mode, glut init window, init func display, reshape. So we'll try to execute it. Okay, did I change anything? Okay, so we'll copy. I have a kind of so flower.png. Now we have two files, flower.png and text. So we'll run this. Okay, so line number 5. So image, invalid syntax, global image equal to none, global text name equal to none, global image text name equal to none. Okay, after all it's Python, so it's tuple, still invalid. Still invalid. Okay, so we'll have separately image equal to none, I think we made other mistake here. It is okay from import. Okay, it is correct. Okay, so something we are doing wrong. From PIL import image. Now global image, global text name equal to none. Okay, line number 29. Unexpected ident. Okay, so I think I am in hurry, so I am putting it here global. Global is not required, so I can just say here whatever I declare that become global. So text name equal to none. So it should be okay. Glut init window is not defined. What we have said, so I think it should be window size. So line number 48. Okay. So bind texture, this function takes at least 2 arguments. So we are giving only one. So we'll set 2 arguments as per the error. Line number 25. Substitute GL texture 2D. Okay. So now GL bind texture is GL texture 2D text name. Okay, let's try our, oh, it came. Okay, so now we have a polygon, and polygon color is set by the texture. So we are not using any GL color. Okay. This is how we map. This is the image. Now, we can have kind of more experiment on it. So another experiment can be, we'll have another one. So we are here. So now we'll have kind of, I'll just copy paste 4. Okay, so same story will kind of, we can kind of tweak it the way we want. So there is another mapping we can try. So I can say kind of 1, -1, 0 and 1, 1, 0. And here kind of 2.4, 41, 1, -1.4, 2.41, -1 and -1.4. So what I'm trying to do is, the same texture coordinate will map to a polygon, and polygon is different in z direction. It is smaller. So if we are specifying z direction, it would be kind of tilted if we see it. Okay, so now we have 2 mappings now. So that we'll see. Now we have 2 textures. One I have mapped like this, kind of this is in XY plane, and this is in XYZ plane. So texture vertex, texture coordinate, and the polygon coordinate. One is STR and one is XYZ. We have to map. So this is what we are doing. Okay, so texture coordinate to polygon coordinate, texture coordinate to polygon coordinate, texture coordinate to polygon coordinate, texture coordinate to polygon coordinate. Okay, now we will kind of experiment other things. We have repeat. There are many: repeat, mirror repeat, clamp. So we'll see kind of mirrored repeat or repeat. Okay, so we can have so many images that would come there. Okay, so I'll say here. Okay, so I have used repeat. So the texture coordinate starts from 0 and ends in 1. Okay, I can say 2. Okay, so this is x and this is y. So y is 2. Okay, now x is 1, y is 2, x is 1. So in the y direction it is doubling. Clear? So now we'll see the output. Repeating. It is repeating in y direction. Okay. Now I can repeat in x direction also. So for that, we'll specify -1, -1. Okay, 1, 1. So that is x is 1, y is 0. Okay, so -1 in the sense left side is not 0 now. Left side we are saying -1. So -1, 0 is the bottom left corner. Okay, so -1, -1, -1, 2, -1, 2, and 1, -1. So it is going low. Okay, so x is from -1 to 1 and y is from -1 to 2. So in x direction it will be double, whereas in y direction it will be more. Okay, so x direction it is doubled, in y direction it is tripled. So this is the wrapping. Okay, so now we'll use clamp to edge. We can do just experiments. Clamp to border. Okay, so for that we need to specify the border color. Since we are saying clamp to border, so I'll say GL text parameter I, GL texture 2D, and GL texture border color 1. So I'll make it yellow. This is Mr. Yellow. Okay, so border color is yellow and we are saying clamp to border. We'll try. GL text parameter I. Okay, it is never closed. It is closed. Okay, so type error, wrong type. GL texture 2D, GL texture border color. Okay. Okay, so I think line number 21. So I will say F. Okay, I think it should be easy for it. GL text parameter F, GL text parameter. Okay, this is OpenGL. So we'll use FV because this is the vector. This is how it is. So we'll try again. This is clamp to border. Now border color is yellow. Now we are setting a border. Okay, so it is not repeat. So since it is not repeating, there will be only one image, and whatever image we have set, the rest part would be border. Border color we have set yellow. Okay. So we can kind of make it smaller. The border is too big. I mean, no one would like this big border. So I can say kind of 0.2 and this direction. So kind of minus 0.2, minus 0.2, and this is left bottom, this is left up, so this will be minus 0.2, and up we can make kind of 1.2, top right, so we'll make 1.2, and this is also 1.2, okay, right and bottom, so we'll say this is 1.2 and this is kind of minus 0.2. Okay, so minus 0.2, minus 0.2, minus 0.2, 1.2, 1.2, 1.2, 1.2. We'll try. What is there in trying? Okay, so it is not able to understand. Line number 30. Okay, so 0, 2 is 0.2. Far better. So now I have an image and it has a border. So this is what is kind of the wrapping we can specify. There are many other. Okay, we tried this and we tried repeating. There is a mirror repeat, there is clamp to edge. Whatever is the edge that will be clamped, that will be stretched. Okay, so that can be tried. Okay, so mag and min. So we have placed the nearest. That will make sense in kind of a MIP mapping. Okay. Now MIP mapping, if we want to try, then we have to kind of use transformation. Okay. So here also we can use transformation, I believe. Okay. So transformation of the image. So for the transformation of the image, we will use a kind of little bit different code that will do kind of magic that is called transformation. Okay. So we have used bind texture. Here we can do transformation. We can write like GL matrix mode, GL texture, GL load identity, GL rotate some kind of 20 degree, and that is in Z, along Z axis. GL matrix mode, GL model view. Okay, so what we are trying to do now is, this is the extra code we have put. Okay, so we are doing all the manipulation against a texture object. We have not entered into texture unit, that is anyway behind the scene, that we are not using now. So the default texture unit is the 0. So texture object is a kind of just a database, but active entity is texture unit, that is behind the scene. Okay, whatsoever, we'll see the texture unit. So this is the texture object. We are binding text name, and it is a replace, and then we are doing matrix mode, that is texture, loading identity, doing rotation, again coming back to the model view. That is what we are doing. rotated. So this point is the 0, 0. Means in image, the bottom left is the 0, 0. So against the 0, 0, along the z direction, so the computer screen is in xy coordinate. So z would be in the direction of kind of coming outward and along the user. So if we rotate in the kind of in positive direction, positive angle, then it would rotate like this. So this is what is the kind of transformation we can do inside the image. Okay, so we have seen so many things. Now we'll kind of move to okay, so global transformation kind of stuff. So that will make more sense. For that we'll have keyboard so that we can do the global transformation. Okay, so we are here down the display. So I'll kind of do insert mode, will do keyboard. So I have a function called keyboard. This is the Opengl function, key xy. We'll have a global transformation, shape, global util I. So these are the kind of little heavy thing that we are pushing in. Global draw axis. Okay. So we'll be safe converting it to bytes, the key. If key equal to, if is tab, so this is tab. If key equal to tab, shape equal to shapes. Shapes, index shape plus 1% len shapes. So we'll see, means this is not a magic, it is kind of, there is some logic behind it. So we'll use util C and keyboard. We talked about Opengl package, key transformation of the shape. Okay. If key equal to verbose print, then we'll use pretty print. So util C dot pretty print. Shape is shape. Transformation equal to transformation coordinate. Okay, so we are not using coordinate system, so I think this much only. Okay, so we have to pass a kind of a dictionary. So this would be this. So this is pretty print, the dictionary what we pass, and that would be printed in a pretty way. So we have written all this code. So if key equal to, so this is for drawing the axis, then draw axis equal to true, else L if key equal to B, capital A, draw axis equal to false. That's it. So this is the code that we are adding for the keyboard support. Okay, so and shape equal to shapes index, shape plus 1, shapes, keyboard transformation shape, okay, so pretty print we did. And then okay, so we'll add this here. Glut keyboard function, there is a one keyboard function, and we'll name our, so now if there is any keyboard, then it will come to, okay, here. Now in global we'll have some declarations now, so we will have kind of shapes equal to global. So this is how we do kind of, so global and image. So these are the shapes we are talking, and default shape is global, okay. And then we have util I is util C, the instance of the util C, and draw axis equal to false. So we will import, so I'll say kind of from Opengl util import shape class and util C. So we'll copy Opengl code here. We have 3 files now. So Opengl, from Opengl we are importing. So this is kind of, we are adhering to the design what we placed. So this is the code we are kind of, so this is our program, and program depends upon the Opengl util. And we have installed the Python 3 Opengl. Opengl util, it has 2 classes, shape and util C, that we have imported. Okay, global and image is here. So now in the shapes display, we'll change the program. Okay, so now display would be different little bit. Okay, so we'll say like here we'll add GL push matrix, GL translate. Okay, so translation from there we'll remove and we'll place it here, kind of 3.6. Okay, and util C has transformation draw axis function, and that function does transformation global. Okay, and kind of what we want, so I can say like okay, so these are the few things that I need to add. So I think it would be relevant once we see the output. If draw axis, else none. Okay, GL push matrix. Okay, and here we'll copy the same thing. Okay, GL transformation draw axis. Here it would be image now, and 2 1 draw axis else none. Okay, so we'll have pop matrix here. So I'll say GL pop matrix. Twice we have used, and we'll comment this. We don't need. Okay, so what we have done is we have passed the translate to display function, and here in the translation we have done the smart translation. We are doing the transformation of the keyboard, what we are placing. So I'll show the code. So once we do the transformation, then it is kind of, it will do global. Then we have push matrix again. It will do local. And then we'll draw the stuff and pop the matrix. Okay, so we'll try now. Okay, from Opengl unit, line number 5, we have to search. GU is GLU, Opengl unit. Okay, so no attribute, transformation, draw axis. There is nothing called transformation draw axis. Transformation draw axis. Okay, so I think it is transform draw axis. So MATION is not required. Transform draw axis. We'll try again. Has no attribute, transform draw axis. So we'll do kind of grep transform draw axis in Opengl util. Transform and draw axis. So that is the function. So 32 substitute transform and draw axis. Transform and draw axis. Again error. Transformation is not defined. Okay, so I believe transformation is a global object. Oh, shapes. Okay, so transformation that we have to define in the global form. Okay, so transformation is a kind of kind of a hash x equal to for x in shapes. Okay, so transformation is a hash, and where each element is a kind of array. So array of the transformation. Line number 8. Oh, better. Okay, so I should be able to do the transformation the way we have added. Now, kind of, I can move to right. I'm not able to move it to right. Missing one required argument transformation. Okay, transfer. Okay, so we'll use util. So we have instantiated it. So probably we'll use util I keyboard. I mean, this is not a, so in the Opengl def, okay, def keyboard. So it's a kind of non-static function. So there we need to provide the object. Okay, so I think we have, so once keyboard is done, we need to kind of refresh it. So we'll say glut post redisplay. Okay, now whenever we press the key, then it should call this. Okay, so we'll try again. Okay, so I'll press tab and it will go to images, and I can press right, so image is moving. Okay, if I press axis, so this is what I was trying to say. So there are two axes now. One is global axis. This is global axis, what we see. And what we see here is local axis. So, where we are, I can see in the V. If I press V, then we are in the global axis. Okay. So, I think we are in the image axis. Okay. So, now if I rotate, it would rotate across the image. So, I can rotate along x-axis, y-axis, full image, or z-axis. Okay. Now, if I press tab, then I'll come to global. So there are two things in the code. Okay. So I have pressed tab. Now I am in the global. So if I say V, then the shape is global. Now I can rotate complete. Okay. So globally we can rotate. We can see it is rotating through global y-axis. If I want local, then I have to press tab and it would go in local. Now, if I rotate, it would rotate in the y direction along the local coordinate system. There only if I want grand, then I can press G and then it would rotate in the grand. So many ways we can do. But what we see is whatever the transformation we did for the image in the image kind of image transformation, that is retained. And then in global way we can rotate whatever that happened. So this is what we tried showing in the kind of theory part. If we do the kind of image rotation, okay, so this first we had image, we rotated the image transformation, but along the kind of, if we rotate the image along the global axis, it would rotate retaining the transformation. Okay, so now, so I believe we should show the code. Okay. Okay, what we did, now we have a transformation for two shapes. One is global axis, one is the image local axis, and both are empty array. And in the keyboard, if I go to the keyboard function, both are filled up through the util keyboard. And once they are filled up, in the display, there are two push matrix. One push matrix translate so that it go kind of behind the scene, and in another push matrix we show the image. Okay, and then we do 2-time pop. So this is, I think we covered. Okay. Okay, so we okay, now this is lab session. So in kind of in lab session, Okay, so in lab session, we covered the design, texture object, texture function. Okay, so next we'll cover, so we covered this. Okay, now texture function, texture object we have covered. So texture function we have covered only kind of replacement. Now we'll see the decal. So decal in the sense that if there is a background texture, then and foreground image, then there will be equation like this. So CS is the foreground and CF is the kind of background. So background is depend upon the alpha factor of the foreground. I mean, this is the equation. So it is kind of, it would blend the pixel color and the texture color, it would blend and it would bring like this. So that we'll see. Okay, so I think we'll remove the idea of clamp to edge. So now I'll say repeat. Repeat, and here we don't want this, we don't need this, and here we'll stick to kind of 0 0 0 and 1 and 2, 1 and 1 and 1 and 0, so that it would kind of complete, it would do. And here we'll have GL color 3F, so I can make kind of green the way it is, so that is 0 1 0. So now there is a color, vertex color. If there is a vertex color and model is the kind of flat model, so GL, this is GL flat model, and so this would kind of span over all the area of the polygon. So color is there, and we have like this. Now here it would not be replaced. I mean, I can do replace. We'll see the output. Okay, it is doing repeat, and we are using transformation. So we won't use transformation, or we'll leave like this. So this is replacing. Now we'll go for decal. Okay, so we are replacing. Now we want decal. It will have some equation, and in the decal it would use, so whatever the alpha we set, so alpha is 255, so there won't be again nothing. Okay, no blending. Now we'll use alpha, so I'll say image dot put alpha and kind of 200. I think this is a decent figure for the alpha. Okay, so image dot put alpha 200. Now there should be blending. There is blending. There is blending. I mean, there is blending. And if I remove this, I mean, if I place the alpha as 255, then there is no blending. It's a crystal clear color. Both are different. Both are different. Okay, so this is how texture function works. So like whatever the alpha we have, 1 minus alpha, so 200, so 1 minus 200, 250, so around 55 would be the background and 200 is the foreground. That much the effect it is showing. I can bring in only background if I want. So I can say put alpha is 0. So foreground image is 0. In that way, only green color would appear. That is the background. Okay, so that is kind of Now we'll move to kind of multi-texturing. Okay. So we'll move to multi-texturing. So that is the idea. We'll close the output. Okay, so idea is multi-texturing. So before that, we will see kind of quickly a MIP mapping. So MIP mapping in the sense that now it will draw, if we see here, okay, so okay, so in MIP mapping we have to create so many sub images, and so what we need to do is, like, if this is the kind of the code, then we are at MIP map level 0. I need to create many images at MIP map level 1, 2, 3, 4, 5, whatsoever, and here in the image, so image would differ, means the next images that we have to pass. Okay, so first we'll see that what is the kind of requirement for the MIP mapping, why we need. So transformation I believe we are doing. So we'll kind of, we don't need transformation right now. And the textures are correct. So we'll run this. Okay, so nothing is coming. Okay, so Mr. Put alpha is 0. So this drama will keep, okay. We'll make 255, that is the maximum. And here GL, so we don't need now. So this story is over. Okay, so blending. Okay, we'll leave it decal, or we can say kind of replace. Okay, so this is the desired image, and now as we talked, this is the desired image, and if I open the program, there is a kind of a transformation is there. Transformation is kind of translate, rotate, and scale per shape. There are two shapes, global and image. Global is the global, image is the image. So if there are many images, transformation will be kind of per image based, and one is global. So what is global? Like if I say go right, okay, I have kind of in keyboard there is something like if I press A, it enables draw axis, and draw axis goes here. So this is a ready-made command which does the transformation and draw axis. Axis is 2 pixel wide. The width of the line is 2 pixel wide, and default is 0.5 length. For local we have set 1 length, so 2 is the width of the line and 1 is the length of the line. So that is the scenario. Now if I press A, So I think it should be visible. Now two axis it is drawing. So left side it is the global axis and this is the local axis. Okay. So if I press V, it shows what is the scenario. Okay, I'll press again. Okay, it is printing kind of some debuggable. So we'll disable this, that is better. Oh, that's what the problem was. Okay, so I'll try again and I'll press tab and I'll say R and I'll say S. So two axes are coming and if I press V, so shape is the image, it is not global. If I press tab again and shape comes to global. If I say global, then all the kind of transformation will happen on the global axis, not on the local axis. So I can say, now I can see the blue line, that is Z axis, X axis and Y axis, and I can rotate like this, the complete image. Okay. If I press tab and say V, I am at the image. Now it will be static, it won't rotate, and if I say Y, the local axis would rotate. That is also again in grand and local coordinate. So this is kind of a local coordinate. Okay. So this much is okay. Means I think this much explanation is okay. Okay, so I'll bring this again. Okay. So right now I am at image, and if I press far, it will go kind of in minus Z axis. Okay. I think someone should see the image carefully when I am pressing far. There is shimmering. It's kind of clear. I'll bring it near. There is shimmering. Okay. It's not smooth, it is coming in front. Okay. It's kind of, there is a something like glaring, something like shining. I mean, someone can see the kind of center of the flower, this region, this portion. So I am pushing it far. There is shimmering. It is more clear now. So this is unwanted effect. Means like, so if I okay, so this is what we don't want. Means how I can avoid this. So as per the theory, if something like this, then we need to create sub images and we have to reduce the calculation amount, that is too high. So for that, we'll go to the code, and the code here. Okay. So I'll say GL generate MIP map GL texture 2D. Now if I generate MIP map GL texture 2D, then automatically it is equivalent to if I have so many texture images and at different levels. So probably this is 1, 2, 3, 4. Okay, so 5 and 6. So instead of that, there is a ready-made command available, and just say generate a GL generate MIP map, and it would generate so many images, and it would bind in this texture map. That's it. Now the transformation should be better. That is the idea. Okay. Okay. So in MIP map, we have to set the filtering as MIP map. So anything we can set. I'll say kind of to not go with high class computation. MIP map. Okay. So this is meaningful in the min filter. So MIP map nearest. So it would select the MIP map image that is the nearest, and then in that it would select the nearest pixel, nearest texel, nearest MIP map. So among these, whatever comes to nearest, like if image size, polygon size is here, then whatever image it finds, MIP map image find the near. Now inside the near MIP map, again the nearest pixel. So no more calculation we are doing. Okay, so we'll try now the shimmering effect if it really goes away. So I'll press for no shimmering. I press near, no shimmering. Okay, whereas here what we saw, if I press for high amount of shimmering, okay, and here if I press for no shimmering, no high amount, there is no shimmering. Okay, if we see the center of the flower, there is no change at all. It is coming smoothly. Okay, I can try a bit more computation. Generate MIP map and texture min filter nearest MIP map, kind of linear, and this is also linear. Okay, now I'll press for again. No shimmering. It is completely flat. Nothing is there. Okay, it's a plain image. I mean, it's anyone can see this. There is nothing. Plain image is gone. This is the advantage of MIP mapping. The shimmering effect is gone. Okay, no glare. But in the first case, if I bring it near, heavy amount of shimmering. You can see the difference. See? It looks like it is computing, and that transition it is visible. Here if I bring near, nothing. Okay, so this is use of MIP mapping. Okay, so I think I can finish this story of MIP mapping. Now idea is we'll go for multi-texturing. So we'll revert back whatever we have done. So now we don't want those many high computation, and we'll say I'm happy with the linear. or nearest, so that it would be faster. Okay. Now, in the multi-texturing, the images are two. Okay. So, multi-texturing will take, I have a hut image. So, this and this image, two images will do multi-texture. So, that is multi-texturing. Okay. So, I'll generate two now. Two. Or I can comment this so that I can uncomment later. So I can say text name 2 and texture it is generating is 2. In global section I can put one more guy called text name 2. Okay, here also, so that it can be propagated. Text name 2. Yes, Python is amazing. So simple to write the code. Okay. Now we have text name and text name 2, and whatever we have done now, the same story we have to repeat. So probably I can shift this code here. Okay, and 3, 4, 5, 6, 7, 8, 9 to 9 line will young. Okay, I can close this and I can open. So the next diagram is kind of hut.png and convert to RGBA and whatever alpha we want to put. So we will use decal. So alpha we can make something like 50. So flower will be more and it would be less. Okay, and then texture name 2. That's it. So two images are there. One is text name and one is text name 2. Okay, same IMG we are using. I mean, image is being pulled inside it, so it should be okay. Now we'll go to display and we will do the magic of multi-texturing. Okay, so multi-texturing is kind of okay, so now we cannot run away. We have to specify the texture unit. So in which texture unit this image would be computed. The mathematics would be kind of computed in which texture unit. So we'll use texture unit 0 and texture unit 1 in computation. Okay, so when we see GL quad, before that we enable. So everything will happen in the context of multi-texture now. That era of blind is going away. So I have to say whatever I am doing in GL active texture, GL texture 0. Inside GL texture 0, we are enabling this, we are binding the texture and we are setting as replace. So first one is replace is, I think there is no problem. Okay, now we'll come to next. So I think we can just copy paste 4YY. Now GL active texture is 1 and it is 2. Okay, so bind texture to 2, and we'll do kind of decal. So decal is, as we see, decal, the mathematics that is used in decal is this. The alpha of the second one, the alpha of the second one 1 minus and the previous one. So that is 50, we have said. So 255 minus 50. So previous one will be kind of a stronger, and the forward one we can say kind of back and forward, back and front. So back is strong because front AS is low, and CS and AS CS and AS, or I can just copy paste this. So this is AS, CS and AS. Okay. So this is the calculation. Now in the code, the decal we are using, so front would be less. And now the mathematics what we are doing, it is same. Only thing is we need to use kind of multi. So instead of text coordinate, we'll use multi-text coordinate. Okay, so GL quad, and here we'll use, I think this would be too much to change this much code, it is understood. And here we'll say multi-text coordinate, multi-text coordinate, and here we'll specify both coordinate. So I'll say copy paste because both are same. This is how both we are mapping. Okay, we'll do. Okay, so here and here. So multi-text coordinate because for both images, both textures we have to set which texture this is. So we'll specify. So GL texture 0, texture 0, texture 0, texture 0, and here we'll say GL texture 1, TL texture 1, GL texture 1, I think it's pretty clear now. And image width, I think that is the second image, so it's okay. Image width and image, we can specify hard bind coordinates also, but it's okay. So now after this we'll close this. Okay, so we are saying GL end and we are disabling the texture. So disabling the texture means whatever the current is that is disabled, that is the texture 1. So that next one also will disable GL active texture, GL texture 0 and GL disable. Okay, so first disable the texture 1 because that is active right now. I think we don't need this rotation stuff. So there are two textures, texture 0 and we bind to text name, texture 1 bind to text name 2. So texture 2, it is active now, this is behind and it is replacing whatever is previous and it is doing decal whatever is the previous, it is not replacing. And then here multi-text coordinate 2F, and then if I say disable, then texture 1 is getting disabled, then I say texture active, active texture, GL active texture is 0 and then please disable that also. Okay, so we can try our luck. Python 3 text. '73 GL vertex. Okay, so I'll copy this. I have HUT. Okay, I believe HUT 2.2. Okay, so I believe HUT size and something is differing. Okay, this is not the HUT we want. So I'll try. Okay, we want HUT double T. Okay, so we cannot see anything. Means the expectation is HUT should be kind of as a ghost image here, the shadow image here. That is certainly not coming. So we'll see what is the problem we have done. Okay, so we have text and text name 2. And here text name 2 is there. We are generating two textures, text and text name 2. Okay, so we are binding texture to text name and we are pushing the image and then we are kind of specifying the other attribute. Same thing we are doing, we are opening HUT.png and putting alpha as 50. I'll try more, then we can reduce probably 250 so that it would be 200, it would be more visible. Okay, so transpose the image and text name to, and then there is no change. Okay, bind texture text name to, and in display we have set active texture as 0 and text name and replacement, and then active texture 1 text name 2 and mode is decal, and here we have set the multi-texture coordinate texture 0 and texture 1. Okay, so I think here we have made a mistake, so it should be 1 and it should be 1 and 1, same thing what we specify 1. Okay, so I think we can try now, so it should not have been 0 0. Oh, far better. So this is multi-texture. So the hut component is 250, whereas the flower component is only 55. So this is multi-texture. Now I can change, put alpha. 255 doesn't make any sense. Here, this is the main one, as per the calculation. Okay. So whatever is the front alpha, that comes into the picture. So front alpha I'll keep kind of 100. Now, okay, so this is multi-texture. Now I can see that the flower is also there and hut is also there. So the way I'll increase the alpha of the hut will be prominent. If alpha is less, then behind the scene, that is the flower, that will be there, that will be prominent. I can make it bigger. So this is the scenario. Okay, shimmering is there because I removed wave mapping to make it faster. It will go right. I can print the coordinates and I can rotate along x-axis. Okay, no problem, means I can rotate along y-axis. I can move up along the y-axis direction. I can move down. Okay, I can move up in the fixed coordinate, move down. Down. Okay, so I can kind of rotate along the fixed y-axis. I can rotate along the new y-axis. Okay, I can rotate along the global y-axis. You can see global y-axis is rotating. This is the global y-axis. Okay, so we can do kind of a texture transformation, and I can do texture transformation also if we want. I just need to uncomment the code and texture transformation would happen. Okay, so first guy is the target. So first guy would do texture transformation of 20 degree along the z axis, and next one, so flower would rotate. Okay, so flower rotated, where Mr. Hut is same. So this is kind of multi-texture. Okay, so we finished the topics more or less. Okay, now we'll see the specular light component later, and MIP mapping, texture function, multi-texturing, texture object. So we are kind of done. Now the question comes is can we do vertex array? Means it's not possible that the texture coordinate we need to specify again and again. So we need kind of texture vertices should be stored somewhere, and we can kind of do on top of it. So that is the idea. So that we'll see how we can do. So multi-texturing, we'll see. First we'll see the kind of simple way we can do texture coordinate, uh, vertex array. Okay. Okay, so I have vertices that is stored somewhere, so I can just grep on it. Vertices, and okay, so I have vertices. So this is the vertices I already have of a cube. I think four sides of the cube. So I can copy it here. Okay. So this is the first face, second face. I'm sorry. This is the 1, 2, 3, 4. This is the first face. This is the second face. This is the third face, and this is the fourth face. So there are four faces. So cube has 6 faces. I have kind of coordinate of only 4 faces. So rather than typing here again and again, so that doesn't look very good. So that we'll try that 4 face how we can do. So multi-texturing kind of we can just comment it. Or we can keep along, but it will be kind of complex that we are not looking right now. That is not the idea. So only to show the vertex array, that is the idea. Okay, so only one will show, that is the flower one, and here, so only one, text name and GL gen text one. So only one that we'll see now, and then we'll go to display, and in the display we will add kind of so GL active texture. So these are for multi-texturing. So multi-texturing we'll see in this area also, but right now we'll focus on showing the vertex array. So we'll say we don't need only enable. So by default it will be texture 0, text name and text env. Okay. Now we'll say GL enable client state vertex array, GL enable client state GL texture coordinate array. Okay, so we have enabled it. Now we will set the vertex pointers. So I'll say GL vertex pointer and 3 GL float. Okay, and GL vertex pointer, the first is the how many vertices are there, so 3. Type is float. Okay, stride, so it is 0, means we'll specify the full array now. And in Python we can kind of trim any array, so it is called I believe comprehension. So we'll write a comprehension count x for count x in enumerate, or we don't need x. Okay, so I'll just say for count in range okay, so we have a q vertices, so we have q vertices, so q vertices only will iterate. Count in range len q vertices. Okay, now this is the length. Now if not count %5, so q vertices, it has vertices and texture. So if it is 0 or 5, and if these are the scenario for y in q vertices, count to count plus 3. So this is the vertices. Okay, now same thing we'll specify for the texture coordinate. So text chord pointer, but it is only 2, 0, y count in range length of q vertices. If not count 5, but this guy would be 3 to 5. I think it's clear. So q vertices, we have one vertices has 5 thing, 3 are for texture coordinate and 2 are for texture. I mean 3 are for vertices and 2 for texture coordinate. So these are pixels coordinate and these are texel, pixel, texel, pixel, texel. So 5 are there. So okay, so I'll iterate the q vertices. So whatever is length, it's fine to me. And every 5 point, now we'll say count to count 3, that is vertices first 3, and next 2 is texture. Okay, I think I am done. Now we can just say GL draw array, GL quads. Okay, 0 and in kind of len q vertices divided by 5 because there are 5. Okay, so I think we are done. Now we can disable. So GL disable client state, GL vertex array, GL disable client state, GL texture coordinate array, and we will disable the GL texture 2D. Okay, so these misters we don't need now. Okay, so all are gone. Okay, so we don't need Okay, so all a story we have written it again. So nothing is required. Only pop matrix and flush. So everything we have commented. I mean, I believe I can remove these also. So we have commented out everything. Not required. So whatever is now I am inside the display, and inside the display I have enabled the texture and bind texture to text name. So it is in texture unit 0 by default. And then GL text environment replace, okay, vertex array enable, texture coordinate array, vertex pointer, GL text pointer, and draw array. Okay, how many vertices? Length by 5, because every vertices has 5 point, and then we disable it again and disable the texture. We'll try now. Okay, so GL draw array is not defined. So I believe GL draw arrays is the actual code. And function, I think there should be a len and int, so it should be okay. Now we'll try again. Okay, now it should be a queue as per the design. It is a queue. Okay, I can see the it is hollow queue, means top and bottom is not there. Okay, otherwise we are drawing the queue. Now it is quite simple, means we can, if we have the vertices in an array, then we have the queue. Okay, this is hollow queue. 4 sides are there. I can force it to far, I can force it to near. Okay, up, down, right, left. Okay, anywhere I can rotate. So this is local axis rotation. If I want, I can show the full axis and I can rotate along the full axis. So this is GLU perspective we have said. So this is through vertex array. Yes, so nice it is. What is required here is only vertices. If I have the vertices, then the story is over. Only thing I need to put is in the display, okay, only the vertex pointer, and that's it, and just draw it. Okay, so here now we'll have a kind of there is a vertices, big vertices that we can kind of fetch, and we can show that also. If I can show small vertices, then no one can stop me to show the big vertices. Okay, so I have vertices of one aeroplane, the way we are showing here. Okay, so now I'll kind of copy the vertices of aeroplane. So we have these many files. I have copied hut.png, flower.png, aeroplane.obj. Airplane.org, it is generated through Blender, and it has vertices, it has vertex normal, it has texture, and then it has the faces. So these are GL triangles. We can see it is not quad, only triangles are there. So triangles are important in the kind of shaders programming. We'll see. We doesn't take quad. Okay, so we'll modify this code now to have the aeroplane.obj, and okay, so here in this code we will copy one file, that obj loader. So obj loader, it reads the obj file and gives us the vertices what we need. So I can say text from obj loader. Okay. Import obj file. From obj loader, import obj file, and then we'll start the story. So kind of to be a certain that I don't want this, so I can just comment this. So from obj loader, import obj file, and in the display now we'll change this. So enable texture 2D, bind, enable, everything is okay. Here I can say m equal to list. This is the kind of obj file. This is how it works. I'll say airplane.obj file, please read it and give the objects. Okay, so this is what I want. Okay, so obj file, probably this is a class, and we are passing the object name dot objects dot values. Okay, and 0 to 1. So m whatever we get in the m, so we will have vertices in the m. Means there is nothing like anything hidden. I can say like from obj file, import obj file, obj loader, import obj file. Okay, and m equal to whatever with the code we wrote, obj file, okay, it reads it, and we have indices, name, vertices, vertex format, and so many things. Vertex format. So it is a kind of every vertices is 8 in count. First 3 is position, next 3 is normal vector, and next last 2 is the kind of the texture. Okay, other are very big, so I can just type m dot vertices. It is, I think, beyond 1000 or 10,000 or something like that. So this is the code. Now we'll proceed. So vertex pointer is 3, 0, y count lane, so that is m dot vertices. If not 8, because 8 is the stride, and we want first 3, and text coordinate is same, and it would come in the range of m vertices, m dot vertices, and stride is 8, and this meter is 5 to 8, 5 to 8 is 3, 6 to 8. Okay, so normal vector I am not normal we are not taking into the account. That's it. Okay. Now len, rather than doing so many computation, I can just say kind of m dot indices. We saw there was one indices, so number of indices. Quad probably will not work, as I showed. The face is triangles, so I can say triangles. 6 to 8, count 0 to 3. That's it. Okay. So Mr. Aeroplane should come. Only thing in display we are calling it again and again aeroplane. So this we can kind of push somewhere else so that it should not read again and again. We can store somewhere. Probably we can do now. So M list object. Okay. Or we can continue. Means this is not the best way to do it. So these are the files, Python 3 text, GL triangles, okay, there are errors. Q vertices is not defined, where I am looking for Q vertices. Line number 63, that's why I commented it. Okay, so here it is. So this is the nice thing that we comment what we don't want, so that it should pop up the error. Vertices. M dot vertices, we'll try again. No error. Oh, certainly there is a aeroplane. Okay, but there is no transformation, nothing. Oh, it's there. Okay. So every time it is, so transformation is kind of, okay, it is slow because every time we are reading from that point. So this is the, okay, so this is the aeroplane. I think I can place it far. I believe it is doing too much computation. So we'll place this M in the init itself. So M equal to, and every time it is kind of doing the computation of the reading. So that is slow. Okay. So in the init itself, I can say M, okay, and I'll set it M here, and M is also none, M, and now M is available. First time it will read it, and after that M is available. I can set it global here, but if I am reading it, I think it's okay. Means it takes time to type. Okay, so I'll try again. Okay, so Mr. Aeroplane has arrived. I can, so it is quick now, as we expected. I can rotate. So the texture is the flower, and this is how it is written. I can kind of move it up, Okay, so it would go, so this is up, so I believe the next would move it like this. Okay, I can print axis, I can say yeah, so this is the axis. Green color is the y-axis, red is x, and z is not visible. That is kind of in the direction of the plane. Okay, so kind of I can rotate along the z. Okay, I can make it far so that it would behind the scene. Okay, and if I say next, it would come. And if I say z, it will move like this. So this is local coordinate, and I can move up with the kind of grand coordinate, up and down. So, okay, so here this is the texture, not that. So we'll see which texture I can copy. So I can say Nemo. Okay, so probably we want uh, 222 aeroplane.png is there, so I'll copy that. So to delete text aeroplane.png here, and in the text.py I can just substitute airplane flower.png to airplane.png. Okay, so this is set now. Okay, so meta aeroplane is kind of better. Okay, it can really fly. Okay, we can rotate it, I think, along y-axis, and it would come down. It would go up. It would go up. It would go down. Okay, so it would rotate along its own axis. I mean, like this. So we can simulate in this fashion with the texture whatever we want, and we can simulate kind of any fighter jet also. So in the kind of next we'll see shaders. There it will be quicker because we'll use GPU. Okay, we can see the kind of Y. If we press, full, it will show. Now if I say near, it would come near us. Okay, we can rotate like this. And it would move. Okay, so kind of we can simulate. So I'll bring it again. Okay, so I'll print the axis, and then we'll kind of so we'll place it far so that it will be little smaller. If I want to see where we are, then I can say kind of as per the global axis. Okay. Okay. So as per the global axis, we are here. Means we are in minus z direction. Okay. And so I'll keep like this and let it move. It would rotate. Okay. It would rotate again and kind of it would move and it would fly. Okay, so it would rotate and it would come back. Okay, and we believe that it should not make any accident, otherwise it will be like this. Like this. If it meets accident, it will fall. Otherwise, nice. Okay, so see, if I change the kind of, now I have one kind of earth, so I can copy it to delete text. Okay, I have one sphere, so I can copy it as a sphere.obj. Okay, I have aeroplane.obj. Now I have a sphere.obj, and then I have kind of one earth PNG, so I'll copy from, I have one. Okay, so it is Opengl image globe, yes. So I have like yellow map, so I'll say earth, or I can just copy it as it is. Now we'll go to the yellow world map.text. So I'll go here and aeroplane.obj. So here I'll say yellow, okay, yellow world map, yellow world map.png, and airplane. So here I'll say sphere.obj, that's it. Now it is a sphere.obj and texture is yellow world map. Done. Now I'm ready to kind of show it. It's earth. Means this much program I am changing, and now it is kind of earth. I have changed the global axis that I should not have done. So I believe it should be in good shape. Okay, I can scale it. So this is GLU perspective. That's why it is showing near and far and axis in that direction. So probably I'll make it far, and then I can rotate it. Okay, so kind of Africa favorite to everyone. There are lions, so I can zoom Africa. Okay, anywhere we can reach, like if I say X, then this is North Hemisphere, and if, okay, if I say minus X, I'm coming here, I can go to any country, India, okay. So pretty clear, means there is nothing here. Okay, so this is little tilted, that what we can see, because our axis is tilted. Okay. Okay, so I can change the texture the way we want. So we have okay, so image globe. We have other textures also. So I can place like a satellite image. So I can copy image globe, satellite, okay, here, and in the texture yellow stuff, I can just say satellite 5000 2500.jpg. Okay, we'll try our luck. Satellite satellite 5250. Okay, this is the image. Python 3 text. That's it. I just modified the code to have another texture, another earth. Okay, and so beautiful. I can scale, and then I can kind of see. Okay, so I have Africa. Okay, it is little tilted, so we can correct it. I'll try Z. I think this is the correction. Nice. Okay, it is tilted because we are using GLU perspective. In ortho, there would not be any problem. Okay, I think we can try. Means there is no stopping. So we'll use GL ortho, and so GLU perspective. So we'll comment this, and we'll have GL ortho, and that is minus 2.5, 2.5 minus 2.5 into. Okay, so we'll go for width greater than height, or we'll type complete thing. Okay, into HY width 2.5 into HY width 120. Okay, 1 up to 20. If width is less than equal to height, else GL ortho minus 2.5 into width by height 2.5 into width by height minus 2.5, 2.5, 1 and 20. Okay, so I think we have done some nonsense. GL ortho. One. We'll keep up to 30 so that we can kind of scale little nicely. So minus 2.5, 2.5 HYW, 2.5, 1 to 30, minus 2.5 width by height, minus. Okay, so we are done. Now GL translate. So we'll keep up at 8 so that we can kind of rotate. Okay, so we'll try now. Okay, so this mister should not do anything wrong now. Okay, so there is no deviation. Okay, so along x-axis I am rotating. I can bring back original position, and this is along z-axis. I think one is tilted along x-axis. Okay, one is along z-axis, it is 370, other it is y, it is fine. So z-axis will, okay, so now we can kind of rotate along z-axis. Okay, so this is the axis, current axis. It is little bit tilted, so that's why it is showing the tilt. Actually, we are kind of making 10 increment, so it is not coming the way what we are thinking. Okay, so we can scale. And we can rotate. Okay, so India is like this now. So India is like this, the way we want. We can zoom. Okay. If I zoom more, then it is coming out of the projection box. So up to here only we can zoom. Okay, so I can say, okay, going far and coming near, it doesn't make any change in the GL ortho. Okay, I can see Antarctica if you want. So now next we'll see the kind of okay, so we can place whatever map we want, and this is the Earth. Okay, so next, so we saw this, and next we'll see the secondary or specular color and multi-texturing in the vertex array. So vertex array also multi-texturing is possible. So that we'll see, and that's it. So a specular lighting and then multi-texturing in the vertex coordinate, that we'll see. Okay, so we'll add the lighting. Now I will enable the lighting. Okay, so where we can add, we'll add it here. So we are inside the init function, and we'll enable the lighting here. GL enable GL lighting. GL enable GL light. So only one light source will enable. GL will enable normalize also. And this one, the what we are talking, this one, GL light model. So this one will kind of add GL light model I, GL light model color control separate specular GL light model I, GL light model color control, GL separate specular color. That's it. We are done. Now we'll just add the position of the light. So position of the light we can add here. Now GL light FV. So we'll add one vector. So GL light 0, GL position, and we can specify kind of 2 in Z direction, and it is positional light, and GL light FV, GL light 0, and GL specular, and we'll set a specular like this. Now we have to enable the vertex normal vector, otherwise shining will means lighting will not work. So we'll enable normal vector and we'll disable normal vector. Okay, normal vector as we have already seen, so this won't be there, and so instead of vertex pointer it is normal pointer, and it is from 3 to 6. Okay, that's it. So we have a normal array enabled, disabled, enabled, and normal pointer. Now we'll add material. So GL material FV, GL front, GL specular, kind of 4. So 4, 4, 4, and 1. Done. So material we have set. We'll set shininess also. It should shine. Shininess kind of 20. Specular we have set. Normal vector we have set. Okay. So in the local axis we have set the position before the transformation, so that it should not rotate. Light source is fixed. And 1.0, so this is positional light and enable. Okay, so we can try. Oh, so lighting is there. I mean it is visible. Okay. GLU perspective will enable the perspective. Okay, and GL translate will make it near so that it would appear bigger at the beginning only. Okay, so the light source is 2 units away in the Z direction. So if I bring it near, light would go away. Going away, only few pixels are there. And it went away because it is kind of it crossed the light source, and light source is far. Okay, I can rotate. So this is shining. So this is kind of in texturing. The secondary color, the specular color is kind of calculated post texturing. Once texturing is done, then a specular color is added. So nice. I can scale. Okay, it went beyond the light source, but whatsoever. Okay, we'll set position. So we'll use a kind of directional light. Now it will be better. Okay, whatever we do, the light will not go away. It may cross the projection matrix itself, but that's it is crossing. But light source will not go away. Okay, so this is specular. Okay, this is India. Okay, it is crossing the projection matrix. Okay, so this is how it is. Okay, so it is flat. Okay, I think now it is more visible, the shining. Okay, so shining would be kind of in any texture, so will change. So wherever we see yellow world map dot png, substitute that with satellite. Oh, so shining is here again. So no problem. We can bring the axis. So this is the axis. This is grand axis and local axis. So we are rotating along the local axis. Local axis is also getting rotated. Okay, so now along y axis it is rotating, along z it is rotating, along x it is rotating. Okay, through grand coordinate also we can rotate. So fixed y it will rotate. So we can bring it to some shape, whatever we want, in this fashion. Okay, it will not come the way we want because we have it. It is not very fine, it is 10 degree, it is calculating. So in that fashion, it may not come to the origin, what we are thinking, but still this much we can get. Okay, so we can rotate across global axis also. Okay, so this is lighting. Now we can have multi-texturing in the lighting itself. I think it will be too big if I write code for multi-texturing. So I can open the kind of OpenGL utility code, and I can show the multi-texturing. Okay, so in multi-texturing, we are kind of using one more guide, that is client active texture. Okay, so client active texture, client active texture, their material, and then we enable 2D, and then we bind texture, and then one by one we enable it. I think we can do it. Then we'll use this. It will be quite complex. We'll try. Okay. So multi-texturing. So we'll here we had done this kind of stuff. So we'll leave it. Image.close. And there is another image. So we'll remain as hut.png and alpha. Okay, so we are enabling multi-texturing here also, and now it would be kind of instead of 1, 2, so generate texture 2, and first one and second one. Now in the display, code will be for multi-texture, it will be complex. Okay, so we'll do the complex. Okay, so what is in multi-texturing? GL active texture 0, and then GL client active texture. So we are doing multi-texturing in vertex array, and this is kind of precious. Okay, and then we'll have, this is what is in the OpenGL code. Okay, so then material, then all this stuff, and then vertex normal and texture. Okay, so material stuff will shift after the here. Then we enable texture 2D, bind texture text. Now we enable vertex array and we'll push it here. We enable normal array, we'll push it here. We enable texture array, and then we'll draw, and then we'll disable all three one by one. Okay, and we'll disable texture 2D. Okay, so before draw, now in multi-texturing the other guy will come. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now again we have to do for texture 1 the same stuff. Okay, this is texture 1, and again same stuff, 2, and mode and replace. So instead of replace, it would be decal, and vertex array, and same thing. Okay, so vertex pointer are same, but image is different. That's it. Now we will happily draw, and then we'll disable. Okay, now we will kind of now, so we don't want texture transformation. Okay, so this also we don't want. So we'll activate GL texture 1. Texture 1 is already disabled, so 0. Okay, so this is not I am looking. Probably we'll remain it as inactive. I am trying to disable the texture 2. Here it is the code. Okay, so we'll disable texture 2. So active texture 0. Okay, so client active texture. Now we'll disable these three YY. Okay, so since for each texture unit, now when we go for multi-texture, whatever we are doing, we have to do for each texture unit. That is the concept. So GL texture 1 and 2 and decal, and then same story. Okay, draw the array. I believe it should be separate. So disable 3 and disable texture and active texture 0, client active texture 0. Okay, so we will try. Oh, something is there. So I'm expecting hut. It is there. So this is multi-texturing, means earth and kind of hut. So both are coming. Okay. So this is, and a specular is also there. There is a shining and hut. So I think I have one copyright image. I think that I can copy text, copyright image. Okay, so instead of hut, I'll say copyright PNG, and the alpha will make it small, kind of 40, so that it should come in minimum fashion. We'll try again. Okay, so now our kind of this fashion is copyright. Now copyright and the earth both are kind of blended. So this is multi-texturing and vertex array. Okay, shining is also there. Okay, we can rotate, we can scale the way we want. Shining remains. We can print the axis. I think it is okay. Local axis. Okay, now local axis is visible. Along the local axis I can rotate. So this is perspective. Now I can, along x-axis I can rotate like this. I can bring to the original shape. Okay. Okay, so this is multi-texturing, lighting. So we have finished all the topics, what we kind of had. Okay, so MIP map, specular light, texture function, multi-texturing, texture object and designing. Okay, so we have one shape class. So kind of through that we can have, like what we are doing now is in the code, if you see, then we have only one sphere dot obj, and that we can replace. We can have many, I mean countless images we can kind of try here. So for that we will kind of will mask everything, all the story whatever we have done, okay, except lighting. Okay, so and here we'll have kind of different shapes that will come into the picture. So I can say airplane equal to shape, ob equal to. So okay, so what is the ob? So here it is sphere dot airplane dot ob. Okay, and then followed by what is the texture. So texture we can, so this is ready-made library that we have written. So that I am showing kind of yellow map, yellow world map.png. Okay, if there are other things that we need to mix it, so I'll say copyright.png, and 40 is its alpha, and specular. So this much code what we have written on the top we need not write. So 4 0.4 and 0.41 and shininess equal to 20. Okay, so this is Mr. Aeroplane, and I think we wrote about the earth. So aeroplane will keep it simple. So this is, I think, earth, and it is sphere. Okay, and then yellow. So this looks even better. And in aeroplane we will have aeroplane.ob, and texture we will have kind of airplane.png, and copyright and everything will leave. So now we have aeroplane and earth, two things are here. So in the global we'll have kind of airplane and earth. Okay, so we'll kind of comment this all together so that it should give error if we are doing nonsense anywhere, and we'll have airplane equal to earth equal to none. Now we have imported from the OpenGL util, shape is the class, util C is there. Okay, so we don't want this text name and text name too, only airplane is there. Okay, all these codes are gone, only two line of code. Airplane, what is the airplane? Ob equal to, texture equal to, that's it. Now in display we are going to use, okay, so this much fashion we don't need now, GL active texture and so many things, so we'll mask it completely. Okay, only pop matrix is there, otherwise we have commented everything from here to here. So only this much code is remaining, that is at the top, GL push matrix and GL transformation axis. Now here we'll iterate. Okay, so I'll say for L shape in shapes, okay, and shapes must not have a global, so I can say kind of L shape for L shape in shapes. If L shape not equal to global, because global we don't want, and here in L shape we'll add, so right now I have image, so I'll say airplane and I'll say earth. Now we have global airplane earth in the shapes, and every time I come here, so first is the kind of drawing the global transformation matrix. Next time we are iterating for L shape in shapes if L shape is not equal to global, and then we are pushing the matrix light V and then transformation. So instead of image it would be L shape, okay. GL pop matrix, okay. So if L shape equal to airplane dot show, if L shape equal to earth dot show, okay. So only this much, I believe the function is display, okay. We just need to display, and transformation anyway we are doing, lighting we are doing, push and pop. Now down the line, so only one pop is required, one pop will comment, that's it. So this way we can have so that client library, library, it takes care of everything, and then we can draw. Let's try. Okay, so it is giving error. Okay, no yellow world map, it's there. Yellow world map. The sphere is not there. Sphere dot opt. Okay, still there is a problem. Key error L shape. So L shape is variable, it's not constant. So 66 L shape. Okay, so whatever in shapes we are iterating, and if it is not global, then we are pushing to the matrix, and okay, then light calculation, transformation for that shape. Okay, so we'll try again. Python 3 text. Oh, now we have kind of okay, so I can press V and I can see the selected shape is airplane. So only airplane would move. So I can say kind of far, and I can rotate along y-axis. So this is kind of multi-texturing, how we can use multiple objects we can use. Okay. Now aeroplane can move separately. Okay. So aeroplane can fly. Now if I press tab, then I'll move to next shape. So that is Earth. Now Earth can rotate. Earth can go left. Okay. Now if I press 2 tabs, then I'll come to aeroplane, and then we have our own fundamentals of the aeroplane. Okay. I'll move it little right, the Earth. Earth would rotate, no one can stop it. I can print axes. So everyone is in own axis, we can see. Earth is kind of, it has own local axis, and plane, it has own local axis. Now where I am, so I have pressed V, so I have selected Earth. Now I can press 2 tab and I come to aeroplane, and then I can, aeroplane would fly. Okay. So now we can see that multi-texturing has taken place. Copyright is at both places. Okay, so we can kind of rotate the plane to come down. Okay, it can pierce the Earth. Where we are in the global axis, that we can see. I'm sorry. So global axis we can rotate. So Earth and plane, so plane cannot pierce the Earth because it is in minus z direction, it is a little away. So I can rotate the plane. Okay. And I can see the global axis where they are. I believe now it can pierce. Okay, it should pierce. I mean, okay, it's still, it is kind of little away. Okay, so I think we have done a lot. We are in aeroplane, so I can move right aeroplane. Okay, so global axis we have rotated. Okay, so that is the scenario. So we can have multi texture also. So I'll show the code again. And this is how we get the multi-texture. So now it is piercing because both are at center, and so we have to come to this stage. Okay. So we are at aeroplane, and we can kind of make it far so that it will be small. Okay. So aeroplane can kind of rotate around the Earth and whatever we want. So we'll get the Earth left. Okay. Now aeroplane is moving. It can move. It can come down. So this is the scenario. It can rotate along one axis like a fighter jet, or I can make it appear like it is coming near us. We can okay, so it would come like near to us. Lighting is enabled, so we can clearly see the shining. Okay, just we can change the texture and we can have whatever we want. Okay, so this is about texturing. I believe I can bring another window so that I can show the code on top of it. Okay, so full story is at the end we have used a library that is inside OpenGL util, shape and util C. Otherwise, this is the code. In init, we did multi-texturing, we did lighting, we have lighting. Now, instead of multi-texturing, we are using library functions like shape. And whatever multi-texturing, we are writing this big code that we have to just pass through arguments. And in display, we just need to iterate, and then we just need to say display. So I think rather than this much, I can just say lShape.display. This is also enough. Whatever the shape it is iterating, so just that is also enough. So whatever else shape it is getting, it is just a display. And these are the story of multi-texturing, that and then rotation, texture transformation, and so many things we have done. We have keyboard, and this is the util keyboard we call because it does the calculation of the transformation matrix and reshape, and that's it. Okay, and then we have so nice, we can so we can simulate kind of the real scenario graphics. Plane can go up, plane can come down, plane can rotate on its own. I can print A, so these are the axes. So plane can rotate like this, plane can move in its own direction. Pretty clear. Now it's a fighter jet. It can go back. Contact us for UML training, for designing training, for Python training, for OpenGL training, or machine learning.